Hi, and welcome to my presentation on Lagom, the newest framework of Lightbend created to architecture microservice applications. Um, during this presentation, we will have an introduction on Lagom and how to develop microservices with it. A little bit about me. My name is Yannick de Turck. I'm a Java developer at Ordina, Belgium. I'm also a Scala and Play enthusiast. I've been using the two technologies for a couple of years now, and as soon as Lightbend has announced their own microservices framework, I just had to have a quick look about it. You can find me on Twitter and on GitHub. I also want to mention the blog post that I created together with a colleague of mine, Andreas Evers. We wrote a blog post shortly after the release of their first version of Lagom. And in this blog post, we are doing a first impressions description, and we are also doing an initial comparison with Spring Cloud and Netflix OSS. It's quite a lengthy blog post, but it should be quite a nice read, so you should definitely check that out. So the topics for today's session, first of all, we will have a small introduction on Lagom, what's it about. As a second part, we will have a look at how we are supposed to write microservices in Lagom. Afterwards, we will have a short demo in which we will write a small application, a small service. We will also write unit tests for it, and afterwards we will also deploy it on a ConductR. After that, we will have a look at event sourcing and CQRS. The two concepts form quite an important part of Lagom. And finally, I will do another small demo on an application that I've written by trying out Lagom, which is called Lagom Shop. So the introduction. So, as I mentioned before, Lagom is Lightbend's newest framework for architecturing microservice systems. The focus is on reactiveness. So, by default, all the services that you implement return a non-blocking response, and that is also achieved together with the Event Sourcing and CQRS approach. In March, they released their first MVP version, and at the moment, they've released a second version in which they've included a couple of new features and some bug fixes. At the moment, it's only possible to develop in Lagom using a Java API, but a Scala API will be coming out soon. So for those Scala developers out there, they just need to be a bit more patient. The design philosophy for Lagom. So Lightbend describes Lagom as being an opinionated framework. With that, I mean that Lagom basically has defined some kind of a golden path with a couple of default choices already made for the developer. For example, everything is message-driven and asynchronous. You have non-blocking API as standard, and Lagom also tries to push distributed persistent patterns with event sourcing and CQRS as standard by default. Of course, all these choices aren't forced on the developer, and if necessary, the developer can deviate from them. Another key concept on Lagom is that streaming is seen as a first-class concept. And all of these things, basically the non-blocking APIs, the persistent patterns with event sourcing and CQRS, and the bounded context that you get with microservices make Lagom a good framework to use in combination with a domain-driven design approach. Developer productivity. So Lightbend pays a lot of attention on developer productivity, and within Lagom you have the same feature that you have in Play Framework. The developers out of there who've already developed with Play Framework know that you have hot code reloading in Play, And what that basically means is that you start up your server only once, and as you implement your code, all these changes will be pushed towards the server, so you don't really have to restart your server. You can just write code and have your changes reflected immediately within your application. So that's really useful. There is also a single command that you can run in order to execute all your to start up all your microservices at once. And last but not least, Lagom takes care of inter-service communication for you. So if you're trying to call a different microservice from your own microservice, you basically only have to inject the interface of the microservice, and Lagom will take care of the communication for you. Architecture and technologies. So Lagom is written in Scala and Java. It is built on top of Play Framework and Akka, which are two other frameworks of Lightbend. SBT is used as the build tool. So it's just an alternative to Maven. In Scala projects, you usually use SBT to build your projects. And another key feature why they chose SBT is that it allows them to create this whole development environment for you. So it's thanks to SBT that you have that single run all command with which you can start up all your services. Then we have the distributed database Cassandra, for which Lagom provides default support. Cassandra works really well with the event sourcing and the CQRS approach that they decided to take. Then we have Juice, which is a lightweight dependency framework. So in Lagom it's used to take care of injecting dependencies. And Lagom is also supported in combination with ConductR. ConductR is another tool of Lightbend. It's basically an orchestration framework with which you can orchestrate deploys to production, and you also take care of scaling with ConductR. So that's just a small overview of all the technologies. About writing microservices then. So within your Lagom application, you basically have the following structure. For each microservice that you have an API and an implementation project. In the API project, you define the interface of your microservice, and in the implementation projects, you implement the microservice that you specified in the interface project. Then we have a project folder in which you can define build properties for your SBT project and also SBT plugins. And then at the bottom we have the build.sbt file, which is like the pom.xml for all those Maven users out there. And in the build.sbt file you define all microservices together with their dependencies, configuration settings, and certain deployment settings. This is an example of an API interface. So you have a public interface called hello service, which extends the service interface. And then you see that we have two methods defined right here. So we have two services defined. We have the hello and the use greeting service. And you see that they both return a service call object with two parameters. The first one is the response, and the second one is the first one is the request, and the second one is the response object. For example, in this case, hello doesn't have a request object, but it does have a string as a response. At the bottom, you see that it's overriding the descriptor method. The descriptor method is used to describe your microservice. So we can see right here that we are describing two REST calls, a get and a post. We map them to a certain URL /API/hello. And as a third parameter, we're referring to the method that we've defined up there. And then you also see that at the end, there is something that says with auto ACL true. Auto ACL basically means that with this setting you can specify whether your API should be whether your service should be accessible externally. So if you put it to true, it will be publicly available. Whereas if you decide to put a single service on undiscoverable, you can use the ACL property for that. The API implementation. So here we have the hello service implementation that implements our hello service interface. And you see that we implement both methods right here. And the thing you'll notice is that what we're returning here is a lambda that accepts a request parameter, and as a response type we are returning a future. In this case we are returning two completable futures, because yeah, in this case there just isn't any calculation that needs to be done, so that's why we are returning a completed future of a string for both cases right here. Then we have the API module. So the API module is actually part of Juice, and within this module you will bind the services within your microservice. And if your microservice uses a different microservice, you will also bind the client for that other microservice right here. In this case, you can see that we have binded the hello service interface and the hello service implementation, and then we've also binded a client for the other service microservice. The first time that you define the API module, you also need to be sure that it's properly defined in your application config. So that's just a setting that you have to do the first time that you've created your microservice module. Registering the microservice. So this is done in the build.sbt file. You can see that we are defining a lazy val for both projects. So we have a val for the Hello World API and then another one for the implementation. And the things we have here is just settings such as version and library dependencies. And on the at the Hello World implementation value, we can see that the implementation project depends on our API project. Yeah, and that's basically it. Other things you would configure here would be other settings in order to build your project. Testing the microservice can be easily done by just executing a curl command, or by simply accessing the URL via your browser. For testing the microservice via a unit test, Lagom comes with a couple of utility classes, such as the service test.testServer class that we have here. And with this class, you can start up a basic server to be used within your unit test. So here you can see that within the test we start up with a default setup, and then we pass on the server as a parameter, and then we can use the server to look up a client. In this case, we have the hello service client that we are looking up, and then once we've retrieved the service, we can look up a certain service from the microservice. In this case, we are looking up the hello service here, and we're passing it a string. And what you'll then notice is that it's doing an invoke on the service. That's because when you're calling the service.hello method, you're not actually directly calling the service, but what you're actually getting is a reference to the service. And that's why you need to execute the invoke method on it. And afterwards you get a future that you can cast to that you can convert to a completable future on which you can then block, and afterwards you can just assert the results. So now a quick demo in which we'll write a basic service. What we will write is a basic service to capitalize strings. So we will have a request and a response object, and in the request object we will basically just accept a simple string that we will capitalize, and this capitalized string we will put into the response. And then we will write a unit test, and finally we will deploy it via ConductR in production. So if I just open up IntelliJ, which is right here. So this is just a basic project with a single microservice. We have an API project right here. So that's that. We have the simple service right here. We already have defined the interface for this, the method for the capitalize. You see that we have a simple request and a simple response object. In these classes, you basically just have a private string as instance variable. And then in the descriptor, we've described the capitalize method as a post REST service. That's basically it. So now we will just move over to the implementation of our microservice. And we can start implementing it. So as you can see right here, what we are actually returning is a service call for a request and a response. If we'll just have a small look at service call, you'll see that it's actually a functional interface with a single method called invoke. You see that invoke has one parameter, a request object, and as a response it will return a completion stage, which is our future. So that's what we will implement right now. So we will take the request parameter that we are getting, and what we'll do right here is that we'll first off we'll just recall it to request because that's shorter. From the request we can retrieve the text string, put it in a variable called our text, and then we can convert it to an upper string, to an uppercase string. Do that just with text to uppercase. And what we'll then have to return is our simple response. So we can just create a new simple response object from our upper text result. Yeah, you see right here that currently we are returning a simple response, but it needs to be a completion stage. Since we've already done the calculation, we can just return it as a completable future instance, like that. And that's basically it for our implementation. We can then try to start up our application. So first off, we have to start up SBT. This could take a short while. Now it's loading the project definition, and as soon as it's launched, you're able to execute the run all command. And if we start up that, if we execute that command, it will start up all the necessary things, such as in this case it's also starting up a Cassandra server, which I've still enabled. But it will also start up our service locator, our service gateway, and finally our microservices. So you can see right here that it has successfully started up our simple implementation microservice, and it's listening on a certain port. Now you don't really have to pay any attention to the port that's been enlisted here. A port is being assigned automatically by Lagom, and we will access our service via the service locator. So I will just move to a different terminal, and in here I've prepared a curl command. So we are doing a curl command with the content type application JSON. It's a post, and we are passing a JSON string to it. We are passing a JSON string with a key text and a value Yannick. So if we will execute this, we should have a capitalized string as a response, which we do indeed. So that verifies that our microservice is actually correctly deployed and working. What we'll do now is that we will write a simple test for this. So in the test folder of our implementation project, I've already defined the basic structure of everything. So we have our server right here, our default server that we will use for our testing. And here we have a method that should test our capitalized service. So what we'll do right here is that first off we will use the server to look up a client. We will look up the simple service client. This. We will capture it into a local variable, call it our client. And what we can do then is call the capitalize method. What we'll get right here is a reference to the service call, so that we will need to invoke, and we need to pass it a request object. This request object will also define right here. So it will be just a simple request of a string. We can use the same string that I've used before, so my name, Yannick, and then we can invoke it. And what we will then receive is the future, so the completion stage. You can just call it the response. And then with the response, we don't really have the value yet, but it's actually just a promise. So what we can do to retrieve the value is that we can convert it to a completable future, and then we can then call the get method on it, and the get method will actually block onto the future just until we get the result back from it. So this should return us our simple response. Just call it our result, and then we can implement our assert statement. So we will just assert it, and we should expect my name in capitals. And from the result object, we will look up the result string. So that should be our test. At the moment, there is a small bug in Lagom where it's currently not possible to launch a service test from within IntelliJ, but a fix has already been made, and it should be released in the upcoming version of Lagom. So as a temporary workaround, we'll just execute the test from within the SBT console. So we'll just stop our server for a bit. And what we then can call is the test method. So here we can see that the test run has started. Now it should execute our test. So it's just starting up. And here you can see that it has started executing our test. It started the capitalized test. And we can see that it has successfully passed. So that concludes our first demo. Now, Event Sourcing and CQRS have also decided to have a separate part within this presentation to talk a bit about Event Sourcing and CQRS, because they actually form quite an important part of Lagom. So it's definitely worth mentioning. So Event Sourcing and CQRS, both of these concepts are actually two separated concepts that don't really have anything to do with each other, but together they actually form quite a nice whole. So what you basically have is that with CQRS, you are actually dividing your persistent layer into a read side and a write side, and both of these sides you can then scale individually. So you can scale out the write side to be very performant to perform writes, whereas the read side can be scaled differently just to be able to consult the data really fast. With CQRS, you are also working with commands. So from your service interfaces, you will actually send a command to your read side. And it's in the read side where the command will get processed and an action will take part. And then we have event sourcing. Event sourcing, basically every change that you do or every record that you will create will actually be converted into an event. And this event will be stored in an event store. And then you will have multiple handlers registered to handle all these events. For example, in combination with CQRS, you will have an event handler defined that will constantly look up all the events that will be created, and every time an event has been created, the event will be processed and the read side table will be put up to date. So that's just a small overview of event sourcing and CQRS. Just to summarize, so with event sourcing you capture all changes as domain events, and multiple handlers can be registered to process these events. Seeing as all these events are stored in an event store, you kind of get an audit mechanism and historical tracing just for free, just because of that. And since you're working with single events, it makes it very easy to write performant code that is also simple to read and is very scalable, because all these events are put into the store and then they can be processed asynchronously in the background of your application. It's also quite nice for testability. And imagine that you have an issue in production, something went wrong, and you're not really sure how the record in the database attained its current state. Well, you can actually just take the event log that's available on production and you can place it locally in your development environment, and then you can replay this event log, and then you can easily debug all the different steps that have taken part in order for the record to have its latest state. Yeah, and you also don't really have any object relational independence mismatch, because the events are, they don't really have anything to do with your persistent model. And then we have CQRS. So CQRS stands for Command and Query Responsibility Segregation. So we have the separation of our write and our read side. And we can scale both sides individually, so that we have a side optimized for performing a lot of reads and the other for performing a lot of quick writes. We can also define different modules, because these sides don't really have anything to do with each other. With CQRS and the read and the write side, you have a feature called eventual consistency. So basically, because in this case with event sourcing, the events are created, they are put into the event store, and then you have handlers that will poll these events. And it's only when the events get polled and handled that your read side is put up to date. So there can actually be a small delay between creating a record and being able to consult it via your read side. Now, just to demonstrate how event sourcing and CQRS is actually implemented in Lagom. So we start off with this. Basically, we have a service right here, and on this service we've registered a processor for our read side. And this in this processor we have a handler defined that will poll the event store. And at the top we have our Cassandra read side, and at the bottom we have our write side. In Lagom this is also called your persistent entity. Then we have our user right here, and the user is trying to create a new order. So via the web interface, he's creating a new order. We can see right here that a create order request is being sent to our service. And in this service, the order request is converted to a create order command that will be sent to our persistent entity. And on the persistent entity, we have handlers defined for handling these commands. So the right handler will process the command for us, and as a result, it should create a new order and place it in memory. And at the same time, it will also create an order created event for us that will be put into the event store. Oops. And in your persistent entity, you can also register handlers for these events. For example, now that the order created event has been created, you can update the state, for example. So now that we've handled the command correctly, we can, for example, send an email now based on the order created event, and we can also return a done to our service, which can then in turn return an OK to our user. And so that kind of concludes the request flow from the user until he receives a response from our service. And then in the background, we have our read side processor that will poll the event store. So it's going to look up any new events. And it should also come across our order created event. And based on the event, it will update our read side database in Cassandra. And as soon as that has been done, the user can look up the order he's just created via any service that consults any data via the read side. For a really good introduction on CQRS and event sourcing, I suggest you look up this blog post right here. Each concept is explained really well in detail, so it's definitely worth a read. Just to give a quick overview, so in Lagom, you have a persistent entity class that extends the persistent entity right here. So in this case, we have an hello world, and in this hello world, you have to override an initial behavior method. And in this initial behavior method, you are basically describing the default state of your persistent entity. So if a new hello world record would be created, it would start with a default state. And what we also have here is that we define multiple command handlers and event handlers. So right here we are defining a command handler for our use greeting message command and an event handler for our greeting message change event. Yeah, and those command handlers will then process the command in the event for us. Then we have a state class. So the state class basically describes the state of your persistent entity. So you see right here that the world state that I've defined right here has two fields, namely a message, a string, and a timestamp, which is also a string. And that's basically it. It's just a simple Pojo class. Then we have an example of a command. So right here we have an hello command. It's defined as an interface. And then for each command, for each hello command, we have a class defined as an inner class right here. Then we also have the event class right here. It's also just an interface, an hello event interface with an inner class for the greeting message change event. And here we see right here how this gets implemented within your service implementation. So in your service implementation, you are first of all injecting a persistent entity registry instance. And this persistent entity registry, this can then be queried for looking up a reference for a certain persistent entity instance. So we are looking up the reference for the hello world class for the given ID right here. And once we've retrieved this reference, we can then send it a command. In this case, we will send it the use greeting message command, and yeah, then it will execute the command handler that's registered on the persistent entity. And then finally, I will just show a small application that I've written when trying out Lagom myself. So I've created this simple application called Lagom Shop, and in there I have two microservices. I have an item service and I have an order service. And yeah, as you can see, the item service is used for creating and looking up items, and the order service is used for creating and looking up orders for items. And then I've also created a play frontend within the application that will start up together with the microservices. Oops, it's a bit too fast. So we will switch over to, well, first off we will start up the application. So we also start up SBT. So SBT has been loaded. Now we can start up all our services. I'll execute here an all command, starting by starting up the Cassandra server for us. Okay, so everything has started up. We can see that we have our item implementation, our frontend, and our order implementation right here. And we can try to look it up via the URL. So the application should be available on port 9000. So here we have our frontend. It's really simple. We don't even have a home page. So here we have two tabs. We have the items tab and the order tab. And in the items tab, you can create new items. For example, you can create a new item, a chair. And we'll just give it a price. As soon as we've submitted the item gets created in our backend. And in the front end, it will just open a detail view of the item that we've just created. And if we go over to the items tab, we see that the item is already enlisted. But just to demonstrate the eventual consistency, if we would create another item, for example, a table for $20, and we submit it and we check the items list immediately, we see that the table is not yet there, and that's because the event that has been created hasn't yet been processed by our read side. So it could take a couple of seconds before this event gets processed. But this is just something that you just have to take into account. For example, when creating an item, what else can we create? For example, a glass for $5. So as soon as the item gets created, what the service is actually doing is that in the response, it is returning the object that has been put in memory into the response, so that our frontend can just consult the item that is just created by looking it up in memory in our backend. So we can, thanks to that, we can immediately perform a detail view of the item that we've created. Just in order to be complete, we can try to create an order. For example, I want to order 2 chairs. I will put it onto my name. And this should create our orders in a couple of seconds. Yep, you can verify it right here that the order has been successfully created for the item right here. So you can see that within the application we have our play frontend defined right here, and then we have 2 microservices, the item service and the order service. I'm not going to go into too deep detail right here, but you should check out the project which is available on my GitHub account, if I can find the link somewhere. So right here you have my GitHub account on which I have set up the Lagom shop project, and you can just clone it, and the only thing that you need to install is SBT. On Mac you can just install it via brew install SBT, and once you've done that you can navigate to the project, execute as the SBT console, and then you can start up the project by executing the run all command. And that should start up everything up, and then you can just toy around with it. I've also noticed that we forgot to deploy our simple service to ConductR, so we will just do that quickly before we conclude our presentation. So we're going over right here. First off, we're going to stop the Lagom shop application. And we're back into SBT in our Lagom simple demo application. In the background, I've already started ConductR. So what ConductR actually does is that ConductR lets you create nodes on the fly. It will be run on a Docker, and for doing deployments in development, you can download a ConductR sandbox, which is free because ConductR is actually a commercial product of Lagom, and it's part of the Reactive platform stack that they are offering. But so for development, in this demo, I'm now using the ConductR sandbox, and we can have a look at ConductR. We can execute the conduct info command right here, and what this will show is all the services that are currently running on ConductR. So you can see that it has loaded two services. We have an Elasticsearch Lite, which is part of ConductR by default, it seems, and then we also have a visualizer service. The visualizer service is actually this cool thing right here. So this is the visualizer of ConductR. You see right here that we have two nodes represented by these blue dots right here. And then we have a couple of big and small dots. And these dots actually represent our services that are available in ConductR. You will see right here that yeah, we have a single visualizer node right here that's currently active, because yeah, you can see that it's a bigger dot, and it's also doing this swirly thing right here, whereas the other one is inactive. So what we will do right now is first off we will create a distribution bundle for our application using the bundle : dist command. And for each project within your application, this command will create a bundle. So you see right here that we've created a bundle for our simple implementation project service, and the bundle has been placed in a target folder. What we can then do is that we can move to the simple implementation project, and then we can load the bundle in ConductR. You do it via the conduct load command, and then you can just press tab, and it will be automatically completed with the location of your bundle. So this we can load, and we can see right now that ConductR has loaded the bundle. We can verify this with the conduct info command right here. So here we see our simple implementation microservice being made available in ConductR, and you see right here under run the number of instances that we currently have running. So at the moment there aren't any. Now we can see that we have two small dots added for our simple implementation microservice. And now we can start up a single node. This can be done by executing the ConductRun command, and we'll just specify the name of our service. And by doing this, ConductR will start up our service. We will see this also right here in the visualizer. So here we see that we have now a single node available right here, and it should actually be up and running. You can actually verify this by just doing another curl command. So I will execute a curl on the IP to which the application is listening to. And we see that we also retrieve the expected result. So this means that our application has been successfully deployed into production. What you can also do with ConductR, for example, we actually have two nodes available right here. We can see that only one of the two is actually currently in use. We can actually decide to scale up our simple implementation microservice and to have two instances up and running. You can just retake the run command, and then you can pass on an extra parameter called scaled with the number of nodes you want to get up and running. So we'll just should be scale 2, and now it should actually scale up our microservice to 2 nodes. Here we should see that the second dot should come alive. I think it's this one. No, it's this one. So here you can see that we actually have our microservices currently up and running on 2 nodes, and yeah, the scaling is automatically, the load balancing is actually done for you via ConductR. Okay, and I think that kind of concludes our final demo right here. So for more information on Lagom shop, you can just visit my GitHub URL, my GitHub repository. It's available on this via this URL, so it's just basically Lagom shop. If you Google my username right here, you should be able to find it. And then I've also mentioned the blog post that I've written, so it's definitely worth a read. And another thing I want to mention is the Lightbend podcast. So the colleague with whom I've written the blog posts, Andreas Evers, has actually did a podcast together with Lightbend. Andreas has been actively working with microservices based on Java, Spring, and Netflix OSS, and he has done an interview, a podcast with Lightbend, in which they discuss Lagom, and they make an initial comparison with how it's done in Spring. So you should check that out as well, because it's very interesting. Okay, this concludes my presentation. Thanks for watching, and see you next time. Bye.